Hello. Hey Tony. Hello. Yeah, Tony. We discussing the applications, right? The applications. Now we use the linear first order differential equations to solve a problem. The LDE to solve a problem. What does it say is we have a ball like what do you say that which can bounce. For suppose a person threw the ball up, okay, straight upward with an initial velocity 2 meters per second. The mass the mass of the ball is 0.0427 kg. Okay, the air resistance is acting on the ball, so there is air, what do you say that there is air resistance. Okay, it is acting on the body, so it is acting against the motion of the body. The ball is moving upward, so the air resistance will be the downward the force of the air resistance will be acting downward. Okay, you call it FA, force of the air resistance, due to the air resistance. Okay, and it is numerically in the problem it is given that 0.5 v, where v represents the velocity of the ball at a time t. So this v is a variable velocity of a ball, not a ball, of the ball at a time t. So v is nothing but the velocity at a time t, so it is a function of time. This v given is a function of time. Right, this is the problem they given. Now they asked find the velocity of the ball. The questions are, what do you say that? Find the velocity of the ball as a function of time. So the velocity which is moving upward, you say that it is capital V, and let's say this is small v. I'm just making a round. Okay, so this is small v and this one is capital V. We need to find the velocity of the ball with respect to the time t. Now second one, they asked us to how long does it take for the ball to reach its maximum height. So what do you do? Time taken time taken to reach maximum height. So this is one, this is also asked. So the third one they asked is if the ball is hits from an initial height of 1 meter, so the person is standing on a, let's say, a bench or a stool, so which is of 1 meter height, and the ball is thrown upward from that 1 meter. Okay, then how high will it reach? So they asked us to find, in this case, find the maximum height. Okay, find the maximum height. So see, this is the ball. What do you say? So there is a force acting on the ball which is against its motion is gravity. Force due to the gravity. Okay, force due to the gravity is also acting downward. So the solution will be like this. Okay, fa is given. Okay, well, that is 0.5 v, and by the Newton's law of motion, what we know is force is equals to m into a, that is mass into acceleration. We already gone through such physical equations. F is equals to m into a. So where a is acceleration, m is the mass of the object. So in the now the force due to the gravity, Fg, is m into g. Okay, where g is nothing but acceleration due to gravity. Acceleration due to gravity. Alright, now so it is, we take the g as 9.8. We know the mass of the object, mass of the ball, that is 0.427 0.0427 grams, into, we take the acceleration due to gravity as 9.8. So Fg comes as okay, we'll keep it that way because there is no need to do the calculation right now. But the force, now we have the force which is acting upward. So this is the force caused by the initial velocity v. Okay, so this force, capital F, balances both Fa and Fg. This Fa and Fg. So the force, capital F, is equals to both sum of the both Fa plus Fg. We know the force has the direction. So if we take capital F is positive, then is this Fa and Fg is acting opposite directions. So we will have a negative sign here. So capital F is equals to minus Fa minus Fg. Okay, now we will find what is this force, what we can substitute in this. So this capital F, as from the Newton's law, we take the force is equals to m a, mass into acceleration. What is the acceleration? Acceleration is nothing but the rate of change of velocity. So we take mass, it is already given, the small v is the velocity of the ball at a time t. So we take that small v differential as the acceleration, so the force becomes m into dv by dt. As we already know, m is 0.0427 into dv by dt. So now we substitute all the parameters in the equation. Let's say this is 1 in the equation 1. So it becomes 0.0427 dv by dt is equals to ma. We have f minus fa minus fg. So we have minus fa is nothing but 0.5 v, right? Fg means minus 0.0427 into 9.8, right? So if I cancel out 0.427 and divide the entire equation with the number 0.0427, we get dv by dt is equals to minus 0.5 by 0.0427 v minus 9.8. So this would become minus 11.7096 v minus 9.8. Okay, this is the equation. See this, v dash is given, v dash is equals to minus 11.7096 v minus 9.8, right? So we'll go to that okay, and do the 7. Hello. Yeah, buddy. Okay. And now we have a linear differential equation, first order linear differential equation, that is v dash is equals to minus 11.7096 v minus 9.8. This we can put it as 11.7096 v is minus 9.8. So in order to solve this, we already solve how to solve the linear, we already know that how to solve a linear differential equation. So it will be like finding the integration factor. The if is nothing but e to the power of integral p of x dx. So here p of x is nothing but a constant, that is 11.7096 dx. So we get the integration factor as e to the power of 11.7096 x, right? This is the integration factor given. Then the solution of the problem V is 1 by integration factor into the integral of integration factor into q of x dx, right? So 1 by integration factor is e to the power of 11.7096 x integral e to the power of 11.7096 x, and q of x is nothing but a constant, that is minus 9.8 dx. Okay, when I solve this, what we get is e to the power of, I'm not going to write all the numbers here, but if you integrate this one, let's take minus 9.8 out of the integration since it's the constant. When you integrate e to the power of x, it is e to the power of 11.7096 x by 11.7096, right? So this is 11.7096. This one and this one can cancel out each other. So what do we remain? Only is that a constant? Hey, we forgot one thing, a constant c. Since there is a constant, you cannot do it directly here. So we have minus 9.8 divided by 11.7096 plus, you cannot write c here, minus 9.8. This 9.8 is multiplying the c also, c by e to the power of 11.7096 x, right? So this is our v. Now this constant becomes minus 0.8369 plus since c is a constant, you can multiply a constant with minus 9.8, it is also becomes another constant. So you can write total c into e to the power of minus 11.7096 x, right? So this is our v. Now we have the initial, so now we solved the solution. Now we found the v in terms of an x, but we have an unknown, that is c. If we found c, then we have found that entire solution, right? How to find the c? There is a clue that given initial velocity is initial velocity is 2 meters per second. That means velocity v at a time 0 is nothing but 2. So when you substitute this one, v of 0, substitute 0 for x wherever in the equation. Let's say this is equation 2. So v of 0 is minus 0.8369 plus c e to the power of minus 11.7096 into 0. We know v of 0 is 2 minus 0.8369 e to the power of 0. The total one becomes e to the power of 0. So the c into e power 0 is 1. So it remains the c. Now c is equals to 2.8369. So we found v is equals to minus 0.8369 plus 2.8369 e to the power of minus 11.7096 x. This is the solution we got. Now we find what are the questions they asked, right? Let's save this one. Okay, now we clear the board. Okay, what do we got? The solution, we got the velocity of the ball. Yeah, let's take the blue. The velocity of the ball v of t is nothing but minus 0.8369 plus 2.8369 e to the power of minus 11.7096. I have that. Yeah. Let me adjust a bit here. Okay, this is v of t, velocity in terms of time t. Now the questions they asked is, the first question is find the velocity of the ball as a function of time. We found the answer for the first question, right? How long does it take for the ball to reach its maximum height? Okay, when the ball which is thrown upwards reaching its maximum height means, and then just wait. Modu. Yeah, sorry for that. And then it comes back, right? The ball comes back. So when it reaches the maximum height, the velocity of the ball becomes the 0. So here v of t is 0. If you find the point where v of t is 0, then we are able to find that time t. Okay. Okay, this is we find in terms of x. So let's say the equation here is t. Why? Because the v of t. So we see here the t. I'm changing it now. Okay, not in terms of x, in terms of t. That's my bad. If v of t, we equate this v of t is equals to 0, then we have to equate minus 0.8369 plus 2.8369 e to the power of minus 11.7096 t must be 0. That means e to the power of 7069 t is equals to 0.8369 divided by 2.8369. How much it is coming there? This one is approximately equal to 0.295. So now we know that if we have e power a is equals to b, then a is equals to ln b. So e to the power of minus 11.7096 t is equals to 0.295. So we will have minus 11.7096 t is equals to 0.295 ln of 0.295. Now t is equals to minus, let's say, 1 by minus 11.7096 ln of 0.295. Okay, so when we find out what is this is, we know ln of 0.295 is also going to be negative since this value is less than 1. So the ln of any value that is less than 1 other than 0 in between the values of 0 and 1 will have the negative value. So the negative value divided by negative value will become the positive value, and its approximate value is 0.104. Okay, so therefore t is equals to 0.104 what do you say that seconds. So it reaches its maximum height when t is 0.104 seconds. That means within 0.1 second it is reaching its maximum height. Okay, now we found this one also. They asked the second question also. So now we have the third one. What does it do is, the third one, find the height of the ball. Third question they asked is, okay, when the ball is thrown from a height of 1 meter, if the ball is thrown from the height of 1 meter, then what is the maximum height that it can reach? Okay, it will go like this and comes down. Okay, let's assume this is the maximum height. So 1 meter plus the height of the ball that can reach its maximum height. Okay, so 1 plus the maximum height that can maximum height that can be reached by ball. Okay, 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 we will find what this is. uh, we'll find what this is. Now we know the velocity v of t is something. That means this one 0 minus 0.8369, the equation of v of t. We know that since v of t is nothing but the rate of change of the height, the differentiation of the height or distance is called the velocity. In case it is the height, not the distance, you can say it is particularly the height. So we write h dash of t is equals to minus 0.8369 plus 2.8369 e to the power of minus 11.7096 t. Okay, now we know what is this one. This is also a linear first order differential equation. Linear first order differential equation. Okay, this is linear. So we'll solve this, which is the form h dash of t is minus 2.8369 e to the power of minus 11.7096 t is equals to minus 0.8369. Okay, so this is how. Now we try to find the integration factor and all. Okay, so we try to do that. Okay, I'll choose the green here. So the linear first order differential equation is h dash of t is equals to not equals to, you can say minus 2.8369 e to the power of minus 11.7096 t is equals to minus 0.8369. Right, now we find the integrating factor. What does it say? How to find the integration factor? That is e to the power of, we know that p of x, integration factor is e to the power of p of x is nothing but another see here Okay, if we approach in this way, see this, e to the power of minus 11.7096 t dt. Okay, we will get this integral is nothing but e to the power of minus 11.7096 t divided by minus that e to the power of minus that number divided by minus that number, right? Afterwards, what you need to do, the integration for this. The solution h of t is nothing but 1 by integration factor into q of x dx, right? So we will have this one, right? So this needs to be integrated again, which is not a very wise move. So what do we do is, see here, the let's say we take back, see here, take this equation, what is it, h of t is equals to 2.8369 e to the power of minus 11.7096 t minus 0.8369. So we directly integrate it. h dash of t dt is equals to integral 2.8369 e to the power of minus 11.7096 t dt minus integral 0.8369 dt. So we know this is a constant, this will come out of the integration, and this is e power ax. So the integration of that will become 2.8369 into e to the power of minus 11.7096 t by minus 11.7096. So the integration of this one, this in second integral is nothing but 8369 t plus the integration constant. Now what is the value do we have? This number 2.8369 divided by minus 11.7096 is equals to minus 0.2423 e to the power of minus 11.7096 t minus 0.8369 t plus c. So this is nothing but h of t. We integrated it, right? h of t. Now we have an initial condition to find what the c is. We have an initial condition. Okay. What is that initial condition? When the time t is 0, our height of the ball is what do you say, that 1 meter. It is thrown from 1 meter height, right? So when t is 0, h is 1 meter. So you can say that h of 0 is 1 meter. In the previous page, as I said, it is 1 plus the maximum height that can be reached by the ball. So where that 1, we are embedding that 1 into the maximum height that can be reached by the ball, right? If we infuse this condition, so no need to add 1 again. So if we know this one, if we use this condition, we will find the c. Okay, h of t, h of 0 is nothing but so substitute 0 in this, in the above equation, so that e to the power of 0 is nothing but 1. So we will have minus 0.2423 into 1 minus, so if I substitute 0 here, that means minus 0.8369 into 0 plus c is equals to 1. Therefore c is equals to 1 plus 0.2423. So we have found the c also. So he asks us to find what is the height, what is the maximum height that can be what is the maximum height that can be so we know how h of t is nothing but minus 0.2423 into e to the power of minus 11.7096 t minus 0.8369 t plus 1.2423. Okay, this is the equation. Now the maximum height that can be reached by the ball when the time t is 0.104 seconds. So find what is h of 0.104. Then you will get what is that maximum height. That maximum height, I will give you the answer as like this. It is approximately equal to 1.0836 meters. Okay, so now we stop here. In the next we start that logistic equations.